Hello and welcome to NetApp's virtual KubeCon booth. Today we're going to talk about simplifying stateful applications on Kubernetes. Part of that journey is going to be talking about how NetApp, where we exist in the cloud native space and how we view where things are going in the future and how we plan to contribute to that view of the future, how we want to shape things. So let's get started with what NetApp is and our presence on the cloud. You may have seen us around major cloud providers providing something called Cloud Volumes. This is a service that provides enterprise grade sort of storage. So it's high performance, it's encrypting the data at rest, lots of security baked in. Basically everything you need to run a high performance, highly secured application that's stateful. So as part of our popularity within the storage space, we've also seen popularity of storage on cloud native grow. We serve many of the Global 2000 companies, and we've seen their interest in CNCF and cloud native projects sort of balloon in the recent years, that those have also sort of been growing. And that's led to some projects like Trident here. So Trident is a great example of an open source project from NetApp, and Trident simplifies connecting your storage to your Kubernetes cluster. So Trident can take any NetApp storage source and offer it up to a container, anything running on Kubernetes or Docker. That work has involved us contributing some work to the upstream container storage interface, or CSI, and we work across all major platforms, basically. So Trident is something you can try out right now. It's free, open source on GitHub. This solves a big problem when it comes to connecting your storage to containers which are otherwise ephemeral. What we've seen from the people who've adopted Trident so far is there's about 600 organizations that are sharing usage data with us, and across those organizations there's over 6 petabytes of data in management under Trident. And we think that number is going to continue to grow as more companies figure out how to simplify and really start to enjoy the benefits of running stateful programs on top of Kubernetes. That isn't to say that there aren't challenges that go along with that. There's other projects that mix and match Trident with open source solutions like Kubeflow. This is NetApp's AI control plane. This does some really great things in terms of simplifying how to get an AI ML pipeline up and running, but some challenges persist even after you look at solutions like this. So our premise here is that we think Kubernetes is ready for data, but in order to get Kubernetes ready for data, we have to solve 2 key big challenges. The first challenge that's sort of represented in the subtext here is that, a basic stateful application on top of Kubernetes is comprised of multiple components. So even the simplest application, something like a WordPress, WordPress is essentially just PHP in a database. That winds up being a dozen or so different YAML manifests that are deployed to Kubernetes, and a multitude of resources spawn from that. We'll look at that in just a little bit as an example of how complex things can be. So there's a need to deal with an application as a logical unit, even though when the application is deployed, it's represented by multiple different resources. The other need that we're dealing with, or the problem that we think needs to be solved, is just that every application has its own way of doing backups and security and other important sort of day-to-day management beyond just simple installation. And that management and security, that backing up of data, that's something that we think if you can make consistent and pleasant, it opens up a lot of possibilities in terms of the portability of your workloads, the recoverability of your workloads, and that's really the focus of what we want to showcase for you in the rest of this demo. So we'll take a look at WordPress running on top of Kubernetes as just a standard application to showcase some of the challenge there. And then we'll dive into a Project Astra demo, which is our vision for how we think things are going to change and be simpler in the future with Kubernetes. We can make things easy for our WordPress install by using Helm, which is a quite accessible way to install applications on top of Kubernetes. It's a popular package manager type solution. So we'll do that and use the Bitnami WordPress chart. We'll fast forward a little bit to save you some time on the spin up here. Okay, so we took a look at WordPress, and you may have noticed that there are many components to running WordPress on top of Kubernetes. In the case of taking a snapshot, there are probably particular details, particular configuration settings that are stored on the Kubernetes cluster that are relevant to that snapshot as well. So in order to take a good backup that's easy to restore, we want to package that snapshot along with that metadata about those settings running on a Kubernetes cluster. And that's just what we call our backup and snapshot process here. So the application that we're looking at is Project Astra. This is an alpha at the moment. And if you're interested in getting involved in the beta program, I'll be sharing a link at the end of this presentation that can help you get acquainted with that. But for now, let's just click in and take a look at the applications that are running on our clusters. So we have a legacy DB here. It's just a standalone Postgres instance. I could click into that and see metadata about how that's running, so I can see that that is indeed a Postgres instance. Likewise, I can click into prod US Central and see that it is running a Jenkins chart. So this is a Jenkins Helm chart. This tab that we're looking at here is the storage tab. So I'm seeing information about the persistent volume claim and the size of storage that we have here. So this is live data about how the application is running in production at the moment. Part of the value of using a cloud-based service like Cloud Volumes from NetApp is you can easily add storage to the cluster if you need it, or you can change the kind of storage class, the tier of service that you're getting with your application relatively easily. So if we needed to add another 10 terabytes or another 100 terabytes, it'd be relatively simple for us to scale things up and down here. Other tabs will show other information. So these are some point-in-time snapshots that we've taken in the past, relatively recent past, if you look at those created dates there. But this makes it easy to take a snapshot. If we need another, we can literally just click this Create a Snapshot button. There are other avenues for making that snapshot on other pages, which we'll show you in a second. But all that is to say that you want sort of a clockwork system in some way that's going to capture snapshots for you and give you an application that you can easily rehydrate or move around, give you peace of mind that your data is protected, but also make it easy for you to restore that snapshot and test that it works. That's sort of the whole dream that we're chasing after here. Finally, let's take a look at the Overview tab. So this contains information about that metadata that we talked about. So we are running a Jenkins instance, which is a little bit different than WordPress. Jenkins, for instance, stores things on a flat file system, whereas WordPress uses a database such as MariaDB. And part of the dream that we're also going after here is, regardless of how these two applications store their data, when we view them on this app screen, both of them are going to have the same sort of mechanism for doing a snapshot, storing the metadata around how that app is deployed on Kubernetes, what those settings are that are important for getting that snapshot restored and up and running. All of that's going to be captured in this action when we click this snapshot button. So I can click snapshot here. I can also configure some of the details of where this snapshot is stored and named and all that other stuff. This is fine for me at the moment. And then I can just click Snapshot App, and we're off to the races with sort of a manual snapshot rather than a timed or automated kind of snapshot. So this is ensuring that my Jenkins production cluster is stored and backed up, and I can easily restore it. And one example of how you might want to use this in the real world is maybe you want to take a snapshot of Jenkins and move it over to staging to mess around with some of the pipelines. Maybe you want to look at some of the errors that are happening on Jenkins. You want to do something potentially destructive to the service, but you don't want to test that on production. Well, these snapshots and the way we are storing data in this Project Astra system makes it really easy to tinker with those sorts of things. So if I switch tabs over to Jenkins, I can see, we have some pipelines defined for sort of a mock e-commerce site here. We have product pages, recommendations, shopping cart. There's an error with shopping cart. So we could maybe move this whole system over and start tweaking some of these pipelines, maybe redefining them, maybe just explore what's going on with shopping cart, and if there's a way to re-architect things such that that error doesn't appear again. So all we have to do to create a copy of that instance that we want to either name staging or that we want to test our destructive sort of actions on, we just have to click this clone button. And that clone, all that's going to do is either take a copy of the live state as it's running currently in production, or we can look at some of the snapshots that we have recently taken as well. So both options are available to you, whether you want the point in time kind of test of whether your backup and snapshot are working, or whether you want this kind of live cloning of your production app as it's running today. We can also move between different clusters. So at the moment, we're on US Central. Looks like we have a widgets Europe West cluster also added to the system here. We'll look at those in a second. Let's just name this like staging Europe West, for instance. And then we can go through the approval process and clone our application. So we can see that a third element has been added to our screen here, and if we were to click into our new staging EU West, we'd find that this is its own sort of instance. So it has its own deployment. If we look at some of the data that's stored, it has its own set of snapshots. We had 4 for our other system, so this is brand new. This is great. This is exactly what we want. We can take a destructive action. We can do cool stuff. That gives us a lot more flexibility in how we run our applications and manage our infrastructure, but it's also consistent. It's the same sort of interface for any application that we're running. So you may notice on the screen that we have a Europe West and a US Central location. How do we get compute added to Project Astra? So that also is relatively simple, and as stated previously, we hope to support as many clouds and as many deployment targets as possible, so from your private cloud to all the major clouds out there. But for now, all that's really required from Google in this instance is a credentials file. So this is a service account that I've created on Google Cloud. This has the credentials for managing the Kubernetes resources, and this is going to be used to connect to Google Cloud to add Project Astra to a cluster that is not yet added to our system yet. So I can configure all of this, and yeah, we can just see how this works. All right, and it was that easy. So through some movie magic, we fast forwarded, and we can see that we now indeed have a new AP Northeast region in addition to our other clusters. So all that Astra is doing is installing Trident for the storage layer, and then using those credentials to see what's running on the Kubernetes cluster and bring apps under management that we want that backup and storage capability on. The final bit that we should probably cover is just that Astra, while we have this nice UI, it's built with a mindset of automation and cloud native first. So we also provide an API for you to access all the commands that you could get at through the UI here programmatically. Closing out things, we'd like to just discuss the roadmap of Astra with you. We are hoping, as mentioned, to support as many clouds and on-premise options as possible. And as part of that, we're looking for portability. So we want the option to burst workloads to the cloud for taking advantage of those elastic resources. And finally, you may have heard that, NetApp acquired Spot recently. So we see Spot as a cool company that's right-sizing cloud resources for any app under the sun, any infrastructure under the sun. And we think if Astra can grow to support that same huge variety of applications, there's some really cool synergy that can appear between Project Astra's aim and the vision for Spot as well. So we think there's a lot of exciting possibilities to explore in that space. If you're interested in getting involved with Project Astra or trying it out yourself, you can visit this URL and get involved with the beta.